All right, Lane, you're up.
Number 5, I was just taking the antiderivative. It's kind of tricky. Can you go over that?
Yes. So this is page 431, number 5. And we're taking the integral of this from 0 to 24 of 300 times 2 minus the cosine of pi over 12t dt. So first thing I did was, instead of writing it as pi t over 12, I wrote it as pi over 12 times t. Same thing. You okay with that? All right, then this 300 could be coming out in front of the integral. So I don't really need to worry about that as far as the antiderivative is concerned, because it's just a constant multiplier. Okay, so then the antiderivative of 2 is 2t, of course. And the antiderivative of cosine is sine. And then this is pretty darn close to right, but it's not exactly right. So what I'm going to do is I'm going to go off to the side and take the derivative of this to see what happens. Because if it's the right antiderivative, I'm supposed to get that, right? Okay, so I'm going to take the derivative of the sine of pi over 12t, and that's a chain rule. Derivative of sine is cosine, and then you'd have to times by pi over 12, because the derivative of pi over 12t is pi over 12. So I thought that perhaps this was the antiderivative, but I found when I take the derivative of that, I don't get this, I get this with an extra pi over 12. So all I have to do then is multiply this by 12 over pi, because then if I put a 12 over pi here, there'll be another 12 over pi here to cancel with that, and then we'll get there. So that is now the correct antiderivative for that. And then we'll just have to plug in 24 and 0 and subtract to get the final answer for that one. Good? So it's the backwards chain rule that's a bit tricky.
I just didn't take out the t from pi over 12.
Yes.
I thought it was like anti.
Yes, quotient rule.
Yeah.
Yes, anti-quotient rule would be a pain. That's why rewriting it like that was so key. But if you take pi over 12 times t over 1, that's the same as pi t over 12. So that's why you're allowed to do that. Good. Corey, you're up.
54C.
Okay, so the idea here is that you get charged 5 cents for each hour that you're 1 degree above 78.
Like, I think I got like it down. I just didn't know what the on the S. Like the endpoints.
Oh, the endpoints?
Yeah. I didn't know how to find the endpoints for B or C.
It's, well, B says, well, C says for the 24-hour period. So it's 0.24. Well, no, that's not true. I'm sorry. Really, I think you're asking about B,
Yeah.
which I've already done. It's an inequality. So if you don't mind, I'd like you to look at that video.
Can we just do 11 then?
So yeah, so now since I'm ignoring your question, you want to change your question to 11,
Yeah.
that's fair enough. So now for 11, we've already done that one.
Okay, never mind.
Do you have a third try?
I mean, I kind of got everything else.
I'm very sorry.
It's okay.
I hate to put you off like that, but since we only have half an hour, I'd rather do other stuff. Yes, Hannah?
Can you still do 54C?
Yes, I can. So the idea there is that you get charged 5 cents for each hour the temperature is 1 degree above 78. So, for example, let's say that the temperature was 80 for an hour. So it held at a constant 80 for 1 hour, maybe from 3 o'clock to 4 o'clock or something. So then that's 2 degrees above 78 for 1 hour. And you get charged 5 cents for each 1 degree you're above 78. So you get charged 5 cents for that, and then 5 cents for that, right? For each degree hour you are above 78. Is that clicking? I'm not yet telling you how to do the problem, but is this clicking? So this is 1 degree, sorry, this is 1 hour, this is 1 degree. So the area of that rectangle is a 1 degree hour. And then so there's 2 degree hours there. So you're going to get charged 10 cents for that. So what we need to do is figure out how many degree hours are involved here, and then multiply it by 5 cents, and then we'll get how much money we're going to have to pay. Well, this graph, f of t, that we were given, outputs the temperature in degrees, and it inputs the hours. So area is degree hours, because hours times degrees. Okay, so that's why we're going to integrate sort of f of t. If we integrate f of t, we get the number of degree hours overall, but we only want the degree hours above 78, so we'd have to subtract 78 from that. If we integrate f of t minus 78, we'll get the total number of degree hours there are. Here's another degree hour, here's another one, here's another one. And then we multiply that by 5 cents per degree hour. And then that'll give us the answer. Okay, and then from B, I think this is 18.629 or something, and this is 5.231 or something. Do you have the actual answers?
I got it, 5.231, 18.771.
Yeah, I think that's right. Refer to the other video. That, anyway, that should be about right.
Thank you.
That, it's definitely 18.77, I'm not sure about the 9. But anyway. Is everybody else okay? This is weird to have a degree hour. But that's because you get charged 5 cents for every degree you're over for an hour. So that's called a degree hour. Okay, someone else. Yes, Maria.
Can we go over 21A?
Sure. So 21A, we have our parabola. And then we have our y equals x line. And they hit at 4, 4. Are you okay with that? Okay, and then for A, we're rotating around the x-axis. So this gets rotated down to here. So you can see circles from the side. So you want to chop this way to get circular cross sections. So then here is a representative cross section. Okay. So then that has a hole in it. So it's pi times r squared minus r squared dx. And it's, since it's dx, it's from 0 to 4. Okay, so then the radii. the big radius, has to do with the parabola. And if you plot that point, you start here and you go over x and up y. So that distance is the y value on the parabola. And then this distance is the y value on the line. But then we have x's mixed with y, so we need a formula for the y value on the parabola, which is square root of 4x. So we got pi times the integral from 0 to 4, square root of 4x squared minus, and then the other one is just x, y equals x, so it's x squared. Seems like you still have that, so we're still not to where your error
Yeah,
was, huh?
well, I was just confused about the radii.
Okay.
Because, like, I knew it was the pi, like, r squared minus pi r squared. I just didn't know, like, what's that.
So this step right here,
Yeah, it was that,
you 100% on that?
yeah.
Okay.
Yeah.
So that's 4x minus x squared dx, and then you just took the antiderivatives and stuff. Is everybody okay? Okay, was it Caleb that, did you have your hand up?
Yeah.
Then you found it on the list and,
Well, is 21C on there? I don't think so.
yeah, it is.
It is. Okay. Then maybe 37. Oh, never mind. It's on there. I lied.
It's okay.
I know 54A is not though.
54A.
Yes.
Okay.
54A. Final answer.
Sounds good. Okay, to find the average temperature, that's 1 over b minus a times the integral from a to b of the temperature function. Okay, so, and it says, does it say over the 24-hour period? No, from 6 to 14. Okay, so that's 1 over 14 minus 6 times the integral from 6 to 14 of the f of t. What is that, cosine? Yeah, cosine of pi t over 12. Good? Okay, and then I think I asked you to do this one by hand, right? Just to practice this backwards chain rule again, right? So that's 1/8 times 80t minus 10 times the sine of pi over 12t. But then that needs to be multiplied by 12 over pi to compensate for backwards chain rule. And then from 6 to 14. You okay?
Oh, I see where I'm making a mistake. Okay.
Yeah, sure. So that's 1/8 times 80 times 14 minus 120 over pi times the sine of 14 pi over 12. You good?
Where are the 120 over 500?
12 times 10. I went ahead and took that 12 over pi times 10 just because yeah. You're good now then? Okay, so then that has to be minused by 80 times 6 minus 120 over pi times the sine of 6 pi over 12. Okay, so that's 1/8 times 80 times 14 I asked you to do it without a calculator, so I guess I will. I think that's right. So this will reduce to 7 pi over 6. Doing okay? So then 6 times 80 is 480. Minus 120 over pi. Sine of pi over 2, right, is 1. So that could be times 1 if you want, but that doesn't really do anything. So then the last thing you do is you look at the unit circle for this sine of 7 pi over 6.
I'm good, I already
Okay.
fixed that.
Is everybody else okay? Yeah. I can, yes. So 7 pi over 6. Better go over here. I'm running out of room. So what is this I'm doing? I did 21A. And then I did 54A. Okay, so unit circle, 7 pi over 6 is here. So the sine of that is negative a half. No, yes, negative a half. Am I okay? Okay, so I got 1/8 times 1120 minus 120 over pi times negative a half minus 480 plus 120 over pi, because I distributed that negative. Doing all right?
Yeah, I just forgot that it was negative on here. That's all good.
Gotcha. And don't forget, you can leave it like this, right, on a free response question. And they're actually happier in Kansas City when you do that, because then they don't have to read farther than that. Yes?
Just like how far do you have to go?
You have to do all the calculus. So I guess you could have stopped here, although you guys are bad at trig, so you better practice this. So for me, do that. So go to there for me. But on the AP test, you could get away with stopping here. Okay. Is everybody good? Okay, what's next? Yes?
47.
So this is still AB stuff. Oh, it is BC, so it's on 560. Okay. So this is page 560, 47C. And if you would, read me off the X. What's X equal?
3 cosine of pi over 4t.
And Y is
5 sine of pi over 4t.
okay. So I know that sine squared of pi over 4t plus cosine squared of pi over 4t equals 1. because that's true for any number, right? So that's just an identity that is pretty much unconnected to this, except I know that there's sines and cosines, so I know I'm going to use this. Okay, so next I'm going to take the sine and multiply it by 25 and divide it by 25. I can do that because I didn't do anything. And then for the cosine, I'm going to multiply it by 9 over 9. Again, completely legal. Okay, so then the reason I did that is this is 5 times the sine of pi over 4t squared. And this is 3 times the cosine of pi over 4t squared. So then that's y squared over 25 plus x squared over 9 equals 1. And so then that's an ellipse. Good. So sometimes the directions were eliminate the parameter. But they said it in a different way there. They said write one equation involving x and y, but that means the same thing. Good. Okay, what's next? Yes,
There we go, we're 21B.
sure. So on 21b, we've got parabola, y equals x, and we're rotating around the y-axis, right? Okay, so rotating this way, so we need to cut like this. So there's a cross section. So it's dy for height. And it's r squared minus r squared. And this is an x value on the line. This is an x value on the curve. So then you need what x equals. It's y. You need what x equals. It's 1/4 y squared. Isn't y squared equal to 4x? So divide by 4.
I subtracted. That's what
Ah,
the problem
yes.
is.
It's all good.
Oh,
Then dividing by 4 is the same as timesing by 1/4.
yeah.
So that's why I called it 1/4 y
Okay,
squared.
yeah, I got it now.
Good.
It's-
It's all good? Yes.
48C.
This is A, B, or B, C? You sure I assigned 48C? Let's see if I expected that. Oh, yeah, okay, yes, I did, and I intended that. So, 48C, it takes a little bit of a jump, and that's why I was hesitant about whether I should have explained it, whether I should have assigned it or not, but it's a jump you can take. So, this parametric curve starts here and ends here, and who knows what it looks like, but the thing is traveling along that curve, right? Because this is the position function. So after 3 seconds, maybe it's here, and then after 4 seconds, maybe it's there, and after 5 seconds, maybe it's there. So the distance that it's traveling is the length of that curve. So we've never thought of, we did length of a curve, but we never did it in the context of this is the position of the thing. But in this problem it is, because it says at time 0 to 4, the position of a particle moving along a path is given by this. So it's just like this is the classic calculus problem. How many times have I walked back and forth up here, right? The classic calculus problem is motion on a number line. Well, this is taking you to two-dimensional classic problem, where it's motion in two space. So you plug in t equals 3 seconds, and you find out, oh, there's where it is at 3 seconds. And then half a second later, it's there. So the length of the curve is what it is. Good. And then just to inspire you further, well, couldn't then you just have a z-axis? X equals y equals z equals, and then you can have in the real world where things are after a certain amount of time. And that's how they went to the moon, basically. I'm serious, that's how they went to the moon. They had an equation for the path that the moon was going to take and where it was going to enter the moon. And good. All right, what else? The problem is everything you want to ask about is on the list.